telomeres do shorten with age, but where the line gets drawn, though, unfortunately for telomeres, is them being a good marker of biological age, and they're actually not.
Hello and welcome to the BSU podcast, where we show you how to optimize your health and fitness through biomarker tracking and nutrition. If you want to look and feel better, train harder or live longer, this show is for you. I'm your host, Daniel Maggs, co-founder and CEO of BSU. In today's episode, you'll learn about how to optimize your diet through self-tracking, how to measure and change your biological age, the difference between recommended and optimal nutrient intake, and the importance of dietary acid load and uric acid to health and longevity. Our guest today is Dr. Michael Lustgarten. Michael is a scientist in the nutrition, exercise physiology, and sarcopenia laboratory at the Human Nutrition Research Center on Aging at Tufts University. His research currently focuses on the role of the gut microbiome and serum metabolome on muscle mass and function in older adults. Michael is also something of a pioneer in the biohacking space, back from when it was more commonly known as quantified self. He's known for his detailed self-tracking of both diet and blood biomarkers, and his passion for healthy aging and longevity. Michael, thank you so much for joining us.
Sure, Daniel. Hey.
Of all the biohackers I've seen, you're definitely one of, if not the most dedicated when it comes to this kind of tracking, in particular blood. Can you just give us an overview of what you've been tracking and for how long?
Sure. So I started probably 15 years ago. I had the idea that aging is a biochemical process that happens over decades. And if I started to track my own blood tests, variables, and the stuff that's found when you go to the doctor to get a yearly physical, the standard chem panel, the CBC, which includes things like red blood cells and hemoglobin and white blood cells and their differentials, neutrophils, lymphocytes, all that good stuff, platelets. So I figured if I at least started off with that data and tracked it over time, I'd be able to see deviations in my physiology sooner rather than later when, potentially disease and or aging would hit me. I did that about once a year for about 10 years. And then in 2015, for whatever reason, I decided to kick it up a notch. And that's when I started tracking my nutrition and then measuring my blood 4 to 6 times a year. And when I say measuring my nutrition, I mean tracking it with a food scale. So weighing all my food and then logging it using free online software. So I started also doing extensive literature reviews on all of those circulating analytes that are found on those, on the chem panel and CBC. So I could figure out how did these things change with age and how are they associated with risk of death from all causes? With the logic being, the reference range is great, but it really doesn't tell you where you should be. And back in the day, out of ignorance, and I'm sure a lot of people do this, I figured, middle of the range is best. Well, that's not true for a lot of biomarkers. So I did a deep dive, full lit reviews on everything, and then I started to write about it so that other people could also benefit from my journey. And as I was tracking my diet, my goal was to use my diet to optimize my circulating biomarkers. And the only way to do that, because, if I just had one blood test result, there's no way I can, take the average diet for the whole year. I don't have enough data points. So with 4 to 6 data points, I'd have 4 to 6 data periods and 4 to 6 blood test results that correlated with those dietary data periods. And with enough data over time, I could start to come up with correlations for the ability of diet to impact these biomarkers.
You mentioned about reference ranges, and presumably many of these, when they're originally established, were about trying to stop people from getting sick rather than the idea of optimal health. How did you sort of determine from looking at the research what might be an optimal range? And did you sometimes have to think about, avoiding excess intake, for example, when it comes to things like vitamins and minerals?
Yeah, so my approach is whole food based. I try to stay away from supplements as much as possible, unless I have a biomarker that's resistant to change through diet and fitness level and optimal body weight / body composition. So the long story short for that, is full comprehensive lit reviews, looking at as many papers as possible relative to how it changes with age, what's found in biological youth, people who are actually young, what are their biomarkers, and in good health. So trying to look at athlete data, and then what's associated with risk of death for all causes. Now, that being said, there are some things that I do indeed go higher than the reference range or, dietary intake recommended levels. And the net effect is my biomarkers, my biological age is 15 to 20 years younger than my chronological. So I'd say I'm on the right track.
So, what exactly is biological age? How do you measure it? I've heard people saying it's about telomere length, and then more recently that actually telomere length is only part of the picture and there are many more factors to consider. So, how do you see it?
Yes. So your chronological age is basically just the calendar year passes and, how long you've been alive on Earth. Biological age is actually an attempt to identify how old you are based on some metrics, whether they're circulating biomarkers or using the microbiome or other stuff. Now, you could have a biological age that's actually older than your chronological age. You could have a biological age that's the same or younger. And in studies that have looked at the correlation between biological age with chronological age, people who had a higher biological age based on whichever metric, whether it was epigenetic age or a composite of circulating biomarkers like, albumin and inflammation, just the composite of those. So people who had a higher biological age based on those metrics than their chronological age had an increased all-cause mortality risk, reduced frailty and physical function. I mean, all the negative consequences that you can imagine, which conversely, people who had the younger biological ages relative to the old, the chronological age, had lower all-cause mortality risk and better physical function. So in terms of the telomere question, there's a paper published a while ago called The Hallmarks of Aging, which basically outlines 9 things that happen during aging, like, for example, inflammation or epigenetic alterations or mitochondrial dysfunction. So these are hallmarks of aging that happen no matter what the species, basically. So telomeres do shorten with age, but where the line gets drawn, though, unfortunately for telomeres, is them being a good marker of biological age. And they're actually not. And then more recently, just in the last year or two, probably the best quote unquote metrics of quantifying biological age is the epigenetic test. So basically, you look at methylation on DNA for a few or a bunch of different genes. And then, they associate the methylation status of those genes with chronological age, and you can predict biological age from chronological age. But interestingly, and this is kind of why I blog about it like crazy, but, the circulating biomarkers that I measure, in one study, the correlation between a composite of 9 of those biomarkers with chronological age or with biological age, the correlation coefficient was 0.94, which when you compare that with the correlation coefficient for the gold standard, quote unquote, epigenetic clocks was 0.97. So you could make the argument that they're not too dissimilar in terms of their ability to predict biological age. So that's one reason I focus on the stuff that I'm measuring rather than going with the quote unquote gold standard of the epigenetic clocks. As another piece of information there, the stuff that I'm measuring, it's cheaper, with the exception of C-reactive protein, which is about a $40 blood test. Just getting the standard chem panel and the CBC is about $35. So collectively, we're talking $75, $80 for all the stuff that you can get a decent or pretty good biological age quantification. Whereas the epigenetic test, first of all, it's 4 times more. It's $300. And that's the epigenetic test that didn't show an association with smoking. So I'm not sure that I want to spend $300 on something that doesn't indicate smoking as being bad for your aging process.
Yeah, I mean, that kind of testing is really an emerging field. I think it's only a couple of companies that are even offering those tests right now, but presumably we'll get that more sophisticated and cost effective in future, right?
Yeah, and the companies that are offering the epigenetic clocks, like they're not looking at the newest iterations, which are much better than the original ones. But like you said, it's still in its infancy. It'll probably evolve and get much better.
And there's also probably a tension for them in producing something that's rigorous, but also something that's cost effective enough to sell, to build a business. Really the genius of the guys at 23andMe is that they essentially got paid to collect people's data for drug research, right? Which is pretty amazing. So how can we change our biological age? What can we do to reduce it?
So this goes back to, again, multiple measurements over time. I'd say tracking diet is obviously important, but what's interesting is a couple of papers on this subject have been published in the last few years. An increase in life expectancy of 10 to 14 years, whether you're a woman or man. I think it was 12 for men and up to 14 for women. They had 5 factors. So obviously not smoking, having a BMI that was less than 25, moderate alcohol intake, having a quote unquote healthy diet without going into the details of that. And then the fifth one was exercise, which was as little as 30 minutes a day every day. And in the data that they published, the biggest gain of those 14 or 12 years, depending on your gender, was exercise. Like 8 years of an increased average life expectancy came from people who exercise for 30 minutes a day. And this isn't, strenuous weightlifting. This was as limited as just walking for 30 minutes a day. So sure, in terms of optimizing biological age, first, it's important to measure many times a year so you get a full picture of what's going on, or a more full picture than one time point. And obviously diet's going to contribute to that too. But the biggest fitness, like I said, with the 8-year increase in life expectancy, is a huge contributor to that. So whether you're just walking every day or you're doing more to, optimize your fitness, I'd say that should be high on the list. And then the other variable there would be optimal body weight. In basically every animal model, calorie restriction extends lifespan. So keeping your calorie intake at or slightly below your maintenance calorie intake probably is going to do a lot to optimize your biological age. Now, there are people in the calorie restriction society who take it to the extreme and get their BMI to 18 or less and think, oh, well, I'm CR, I'm going to live infinitely long. And, it goes back to, what do your biomarkers say? And what is the optimal body weight, and potentially even splitting that further, body composition that's optimal for your biological age. So, it's not an arbitrary, hey, I'll get to a BMI of 18 and then I'm going to be youthful forever. It may be 22, it may be 24, it may be 26. It can vary. So those are the factors. And then it's for each individual. I don't want to put a blanket statement and say, do this, 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 and this. It's for each individual to self-test and to identify the factors that optimize it in them. When I first started out, I used to go completely based on the literature and the population trends and follow them. And once I saw that, some of them didn't affect my circulating biomarkers at all, I thought, well, okay, that's great for the average population, but that may not work in me, which is kind of what the whole purpose of epidemiology is to make recommendations to the average person, but how people actually integrate those changes. So that's kind of my point, is to self-identify those things.
What would you say are the main changes you made to your lifestyle and diet from self-tracking? For example, carbohydrate restriction, the amount of protein you eat, macronutrient ratios, and so on.
So when I started getting very serious about the role of diet in this process, I went full vegan. And there's actually a Tufts video that I presented, I think 5 years ago, just showing that data. And I did that because at least 5 years ago, the media bias was, oh, if you go vegan and you go completely plant-based, this is optimal for your health. It's better than everything. So I thought, all right, let's see. Let's see what the data says. So when I did that, my triglycerides doubled, which may seem like a lot superficially to hear that they doubled. Still within range, still less than 1 millimolar, which is about 90 milligrams per deciliter. So less than 90 or 1 millimolar is associated with less risk of death from all causes in a huge meta-analysis. So granted, my triglycerides went up to about 90, but my average was about 45. By standard clinical medicine, I'm still within range. But to me, if something's doubling, that's a big jump. And then my HDL went down. And, these are things that are going in the wrong direction. So then I thought, well, okay, clearly full vegan isn't optimal for these two biomarkers. So I'm going to add fish back in it. And I knew from, past measurements that when I had fish in my diet, my HDL went up probably about 25% and my triglycerides went down. So when I added fish, which is basically sardines every day, because I don't feel like cooking, fish every day for 40 minutes, just pop it out of a tin and I'm good. Exactly what I predicted happened. My triglycerides went down, HDL went up, things going in the right direction. So since then, it's a continual trial and error process. I kind of laugh when I see companies that'll say, oh, well, send us a microbiome measurement and we'll give you the diet that's best for you. I mean, I've been doing this now for 5 years, where I've got 5 years of dietary data, 1,800 days of consecutively tracked dietary data, macro and micronutrients, with 25 to 30 blood tests. And it isn't a perfect thing. I'm still trying to figure out at times what's the optimal diet. Like you and I talked about through email, I noticed my creatinine levels going up, which indicates that my kidney function may be going down, which kidney function goes down with age, especially measured by EGFR as a measure of kidney function. So, in all my little dietary experiments to see how it affects my biomarkers, I started to eat more meat, eggs, and cheese. And this isn't to say I didn't eat it before. Maybe before I had it once a week, but now it was more often, maybe 5 or 6 times a week. And I noticed that my EGFR started to go down, which is a bad thing. I don't want to fall into these traps where my biomarkers are following age related trends, in this case, going down. So even though my other biomarkers of kidney function didn't change, being, blood urine nitrogen, uric acid, when I look at the correlation between the sum of my meat, cheese, and egg intake with creatinine, it's a relatively strong correlation, zero point 0.5 to zero point 0.6. It's not zero point 0.8. I'm going to have 7 data points for creatinine with 7 dietary periods. So more data will help to flush out that data. So yeah, I don't like seeing my EGFR values hitting 80, whereas they're usually around 90, 95, 100. And before you know it, they could be 60. So I get your point about, maybe it's not a kidney function thing and it's just a creatinine thing, which is true. But for these things, I tend to err on the side of caution rather than measuring myself to death with other things. But I'm going to cut my meat, cheese, and egg intake, but not touching my fish or whey protein, which I put in my homemade protein shakes, and then see what happens. If indeed I'm eating too much meat, cheese, and eggs, like 5 to 6 days a week, which I changed it to a few months ago, it was never that often, for my next blood test in a couple of weeks, we should expect to see my creatinine levels going back down. Now, whether that's actually related to decreased kidney function, I don't know. But for this instance, I'd have better peace of mind knowing that my EGFR was closer to 100 rather than going in the opposite direction. But it's a constant trial and error process.
You mentioned about your triglycerides doubling and your HDL falling on full vegan, and then those numbers correcting when you added fish back in. Did you try the same experiment with, say, meat, cheese, and egg as a source of protein? Or is it something specific, you think, to fish oils or the nature of fish protein?
Yeah, so fish has got omega 3s. Omega 3s can reduce inflammation, improve intestinal barrier function. There's a lot of ways that it could lead to reductions in triglycerides and increases in HDL. This could get into the role of dietary acid load. But then again, just as an example there, I added full fat yogurt. And it's funny because, I have friends that I'd make fun of them for eating dairy because I'd say, oh, dairy's for babies, and once babies outgrow weaning, they don't consume their mother's milk. But, I had some microbiome testing done and my gut lactobacillus, which is found primarily in fermented foods like yogurt, were basically zero. And there's a lot of positive health benefits of lactobacillus related species, especially as it relates to muscle mass, the gut muscle axis. So I added full fat yogurt into my diet, and for 2 biomarkers, red blood cells, which decrease with age, which isn't a good thing in terms of mortality risk, and hemoglobin, which are found in red blood cells, which for biological youth, for example, red blood cells about 5 and hemoglobin about 15 is optimal. So for me, no matter what I did before I added the full fat yogurt in, I couldn't get my red blood cells back to 5, which I had actually seen in blood test results of my own 15 years ago. So I knew that it was possible. It just, for whatever reason, I couldn't do it. And similarly for hemoglobin, I hadn't been able to hit 15 like I had an older blood test for a while. And part of me was almost resigned to the fact, well, I guess my red blood cells are aging and I'm just aging now, and that's just how it's going to be. But for whatever reason, I thought, all right, I'm going to do the experiment. And I didn't even expect the yogurt to affect those 2 variables. But as soon as I added yogurt into my diet, my red blood cells haven't been lower than 5, whereas over 15 measurements, they couldn't crack 5. And hemoglobin's back up past 15. So the reason I bring up the yogurt, which goes back into the dietary acid load, because from the potential renal acid load PRAL calculation, Remmer's calculator, yogurt has a lower dietary acid load. So for that as a source of protein, I don't include it in the group for meat, eggs, and cheese. I'd say in terms of nutritional benefit, those foods may have less relative to the yogurt, which has got, the lactobacillus species, and the sardines, which have the omega 3s. Whereas meat, cheese, and eggs for me probably have less nutrients that are positively impacting my physiology. Or maybe it's just too much animal protein for whatever reason. That's the next thing. It's, I have friends that are like, okay, sure, you've got this correlation, but is it causing it? And to me, if I see positive changes in biomarkers, on some level, I don't care. But as long as it works and you see things going in the right direction, I'm not interested in going down the rabbit hole of, doing more food-based experiments to figure out what the exact mechanism is. So,
Sure. You mentioned about dietary acid load. For those who are unfamiliar to the concept, can you explain what dietary acid load is and why it's important?
so it's the net effect that the food that you eat has on producing acid in your body. Now, granted, your kidneys should be able to buffer it out with bicarbonate, but the idea is that too much food that can lead to a high acid burden can kind of wear out the kidney's ability to buffer that over time, leading to small deviations in increased acid levels in the blood. And that isn't good. Metabolic acidosis isn't good for lots of different things in the body. Bone loss, just as one example. So then you could get into the carnivore issue, right? With how would you reconcile that data? Because if you're eating just a pure meat diet, it's just pure acid. There's no alkaline producing fruits and vegetables there, right? So
No, it's a tricky topic because I had a chat with someone called Linda Frassetto. She's a nephrologist who's really specialized in this area. And I really feel the waters have been muddied over for dietary acid load by this concept of the alkaline diet, right? It's largely been discredited, but there were some people really trying to sell products based on this idea that you must be alkaline all the time. And I think that really confused some of the good science underneath this. So we know, for example, that the body has to maintain a steady state pH in the blood, and that varies very little. That acidity is removed both, through the respiratory system and also the renal system and through buffers, and that excess acidity has to be excreted. When we're young, we have very strong kidney function. So people who are in their 20s and 30s and probably 40s are not going to suddenly get sick from having a high dietary acid load. However, we also know from looking at people at the older end of the spectrum, because typically people in their 60s and 70s have about stage 2 kidney disease, CKD, so it's not requiring treatment, but it's a stage before that, a significant loss of function. And also from space as well, and things like bone loss in space, that acid load does accelerate bone loss and also loss of kidney function. So the way I kind of say is, look, having a high acid diet, you're probably going to be fine right now. But with more and more of us living or trying to live to 100, we know that kidney function declines with age. So let's make an investment in our health to maximize that longevity. And we also know that there are other potential consequences in terms of muscle function and retention, even muscle performance. Acid load impairs physical performance for athletes. So, that's another benefit to being on the safe side. But it's tricky, right? Because obviously, for example, there are many benefits from being on carnivore. There's the satiety, there's the blood sugar regulation, there's the muscle mass, retention and growth. So I'm not saying it's all bad, but it's tricky when you get into this area because people feel very strongly about the diets they associate with, right? So how do you get that kind of trade-off?
superficially, I think most people would probably think that I would be anti-carnivore, but evolutionarily, there were periods when maybe that's all you ate was meat for a short period of time, right? But was that optimal for health? I mean, yeah, it was optimal for survival. I mean, if you ate, you had more energy to reproduce, and there you go. But say, you roamed a 3-mile radius for all the animals that you could eat, and you caught and ate them all over some period of time. Well, if there were no more animals to eat in your localized region that you could walk to every day, you'd have to eat other stuff. So there are probably periods where, people ate nothing but meat for a few days or weeks or months, but then after that was gone, it was less meat and lots of other stuff. And if you look at some of Eaton's papers, he's published, what was the Paleolithic diet actually like? And I think by mass and volume, it was like 25% animal, but then 75% plants. So when he calculated out the fiber intake of that time period, it was like eating 100 grams of fiber a day, but also high protein, obviously. That's kind of what I'm doing with the blood testing. I always say, what does the data show?
One of the other biomarkers you've been tracking is uric acid. What is uric acid and why are the levels important? Is it all bad or are there positive aspects to uric acid within the body?
Yes, I know this is associated with kidney function and uric acid levels that are too low. I think if I remember below 4 and then too high, I think above 8 are not optimal in terms of risk of death for all causes. So too low, too high, increased risk of death for all causes for uric acid. And then it increases with age. And I get your point. I've heard that argument before too, that how do you reconcile that higher levels of uric acid act as an antioxidant? And what I'd say is if it's higher than 8, even though it may be acting as an antioxidant when considering it's associated with all-cause mortality risk, the net picture is potentially bad. And if that weren't true, you'd expect to see decreased all-cause mortality risk with the higher levels of uric acid. But that's not what we see.
I think it also goes to the point that, information needs to be looked at in context. You could have, for example, someone who has a high pral diet, a high acid diet, because of, say, high carbohydrate intake, grains, maybe even saturated fat. And that could be someone who has, some nutritional deficiencies. They might be from a low-income family, but then there could be someone who's very fit and healthy naturally, but actually eats a lot of steak, for example. They might both have a high pral, but their actual mortality risk may be quite different. That's why acid load itself is not a definitive marker for mortality risk. So coming back to the uric acid point as well, uric acid is involved in scavenging free radicals. But at the same time, it's not surprising that it's also associated with all-cause mortality because a diet high in purines, which can include alcohol, for example, can, but not necessarily, increases mortality risk. So I think that's the point about the more data we have, but obviously in the most easy to collect, cost-effective, painless way, we have more context, we can really understand what's going on.
100% agree. And I try to almost never look at, single biomarkers in isolation. But if we know that uric acid levels higher than 8 are associated with increased all-cause mortality risk, what if your inflammation, like your CRP, just as an example, is close to 0 and your insulin sensitivity is as good as it can get, but you just have, like you said, just, a higher level of uric acid because you've got a high PRAL diet. If all of the other biomarkers look good, especially I'd probably say in that case, if the blood urea nitrogen wasn't too high, in this case, I'd say probably less than 15, somewhere between 10 and 15, and your kidney function was good, whether it's by EGFR, cystatin C, or some other measure. If you've got a high, uric acid in that case, well, maybe it's just related to the high purine level of the diet and everything else is good. So it really doesn't mean much, right? But it goes back to, again, the comprehensive picture, like you mentioned, because most people don't do that. They'll think about it in isolation instead of the whole picture, which tells you obviously more of the story.
All right, Michael. So this just leaves me to say thank you so much for joining us. It's been a great discussion. I'm really glad we managed to get into the weeds and go through some of this stuff. And I'm just excited to see what you'll be working on next.
Me too, for you guys at BSU. So thanks a lot.
Thank you for listening to the BSU podcast. Please subscribe to receive a new episode every 2 weeks and visit our blog at www.bsu.bio/blog to get a full transcript of this show, as well as other content to help you know and grow yourself. Until next time.